Let's talk about primitives in JavaScript. What is a primitive? It's not an object, which means it doesn't have methods and properties. You can still access methods and properties like, but not limited to, length property for strings and toString method for numbers using feature called autoboxing. It's immutable. You can't alter it, but you can assign the variable to different primitive values. We have an example of a variable that is assigned to a primitive value. Primitive types. We have 7 types. First type is a number used for numbers. Example, age equals 67. We console log the type of age just to see the type of the primitive, and this will actually print number, as you can see here. String used for text. An example, hobby equals programming. We console log the type of hobby. It is string. Boolean used to describe two states, true or false. An example is adult. This can either be false or true. We print the type of is adult and we will get Boolean. BigInt, usually used for large numbers above 2 to the power of 53 minus 1, which is the limit of regular number. Example, large number. We can have 67 trillion. I honestly don't know this number, but very big. We can select the large and it's BigInt, as you can see here. Symbol, used to get a guaranteed unique value. An example, this is how we make a symbol. We print the type of symbol, we get symbol. Undefined, used by JavaScript as default uninitialized value. For example, if we declared this variable password and we didn't say anything, this will print undefined because the initial value of password is undefined, basically like this, but by default like this. Null, used by developers to intentionally mark it as absence of value. We console log the type of null, we get an object. Why do we get an object? Because prints object because of bug in JavaScript. But basically null is a primitive value. Primitives are immutable. They can't be altered. Let's say an example. We have variable greeting equals hello. Attempting to change the string directly fails silently or throws an error in strict mode. For example, if we try to change the first letter in the greeting variable, this will not work. As you can see here, it actually prints hello. Reassignment is allowed because it's a new primitive. We are not altering the value itself. So if I change the entire value of greeting, this will actually work. As you can see here, Jello, it works and we can see it here. Pass by value, not reference. Let's talk about this. When passing by a value, we are reserving a new memory address and copying the value. When passing by reference, the variable points to the same memory address as the variable we are passing. Passing by value example, we have a variable a, it's assigned to 10. It reserves an address a in memory. We have another variable, primitive v. This is actually assigned to primitive a. This will actually reserve a new memory address in memory. Let's call it address b, and it will copy the value to it. We will assign primitive v to 67, which is a primitive value. Changing b will not affect a because they don't share the same memory address. Let's prove the point. If we print primitive a, this will print 10, as you can see. If we print the variable b, this will print 67, you can see here, because it doesn't affect primitive a. Passing by reference example. So we have an object a. It's basically a new object with the property of value and value of 10. Reserving address a in memory. When we declare a variable object b and we assign it to object a, we are passing by reference. Why? Because this is an object. So what will happen is that we will pointing to address a, basically the same address for object a. So object b points to the same memory address. If we change the value of object b to 67, changing b will not affect a, and vice versa. Even if we change a, this will not affect b. Even if we change a, this will affect b because they share the same memory address. Let's see the proof. If we cancel log object A and object B, we will get the same value because changing one will affect the other because they share the same memory address. And this is the difference between passing by reference and passing by value. And primitives are passed by value. Rounding error in floating numbers. If we try to add 0.1 to 0.2, this will actually result in this number 0.3, but we will get a very small floating error, which in this case it's very small, but it's there. This will make actually problems if you try to check if it's equal. If we check if this is equal to this will actually obviously be false because it will basically do this, and this is false. If we want to compare floating numbers, we need to do this, and we use a function here, and this function simply checks if the absolute value of a minus b is smaller than number.epsilon. Number.epsilon is bigger than the rounding errors. If it's bigger than the rounding error, it means equality. This basically, and actually epsilon is this value. If you compare it, it's actually bigger than the rounding error, which allows us to ignore rounding errors. Mixing BigInt and number. Suppose we have a very huge number. You cannot mix BigInt and number. If you try to mix the BigInt and number, this is by the way a normal number. Type error cannot mix BigInt and other types. If we actually change it to BigInt like this will work. If we didn't, it will crash the program. You can also do this BigInt and pass the value you want to convert to BigInt. But if it's like a value literal like this one, you can just simply type in and it will convert it to BigInt. Symbols. We have symbol 1 and we have symbol 2. And notice they share the same description. They don't have to be, but I will show you that even if they share the same description, they will still be not equal to each other, and they will never be equal to each other. Symbols are always unique, even if you pass same description. If we check if symbol 1 equals symbol 2, false, not equal. As you can see, false. It doesn't override existing parameters, even if they share the same description that you passed to the symbol. This like simple, as you can see, we pass ID and we already have ID. This will actually not override the ID. As you can see here, we use the symbol as a key. We can put anything here. Symbols don't show up in standard loops. When we cancel log the key in the properties of users, it will only show ID, name. The symbol doesn't show up. Let's see. Yes, we only see ID and name. It doesn't show up. This one is the result of this one. You can see symbol in console log and object.get on property symbols. When we console log this one, object.get on property symbols, and we pass the object, we will get the symbol that we have, which is this one. We can also console log and it will show us the symbol here. As you can see here, this is the symbol, name John, ID 1. Autoboxing in primitives. Variable string primitive only holds the value literal hello. This one, we only have a variable and it holds the value literal hello, which is a primitive of type string, and nothing else, like methods and properties such as toUpperCase and length property. Boxing behind the scenes, it will basically make a new object and it will call the method that we want. This is where the magic happens because you don't need to wrap the primitive in an object. So for example, even though our variable only contains the value literal of hello, we can actually still invoke methods just like this one, even though the primitive is not an object, but this is the power of autoboxing. JavaScript behind the scenes wraps the variable in object and it will invoke the method and get the result back. In this case, we have the value in uppercase. Don't use the object wrapper because it consumes more memory unless you know what you're doing. There is no need to make an object of the type, so this is actually an object. This is not a value literal. It's not a primitive. This is now an object. We have number object. We can also make an object of string and we can access the value of it like this, just like this one.